Hello guys, welcome once more to another video on our YouTube channel. So in this video we are going to be looking at the Southwest Regional Mock 2024 paper 2, question number 4. This question was from two topics: application of calculus and linear transformations. So without wasting much of your time, let's get started. Okay, so the question reads: a linear transformation T is represented by this matrix. Find the image of the line under the transformation T. Find the image of the plane under the transformation T. B. A curve is given by the parametric equations x equal to theta minus sine theta, y equal to cos theta for theta in the interval 0 to pi ln 3. Show that the length of the curve is 4 minus 2 root 3. So we are going to analyze equations part by part. Okay. Alright, let's begin with question A, Roman 1. We have a linear transformation T and the matrix of the transformation has been given to us. Now we need to find the image of a line under the transformation. So the image of a point under a transformation is basically the matrix of transformation times a point. Okay, so it therefore means to get the image of a line, we need to get the general point on the line, and then we multiply the matrix of transformation with that general point. The resulting answer we have is the image of the line. So basically the image of a line is a matrix times the general point on the line. Now we need to get a general point on this line. This line is in space, so we need to get the parametric equations of the line. So to do that, this is the line given to us. We start by writing the line in, we start by writing these vectors in a column form so that you can easily get a parametric equation. So this arrow here is actually xi plus yj plus zk. So the column vector is xyz. Now this, we have 2 negative 3 negative 4 plus lambda into 1 1 negative 1. So if we do the vector addition, we need to add the corresponding unit vector components. We get 2 plus lambda, negative 3 plus lambda, and negative 4 minus lambda. So the image of the line we can call the image of x prime, the image of y prime, and the image of z prime is equal to, we need to take the matrix of transformation times the general point on the line. This is the general point on the line. Okay, since the general point on the line has been gotten from the parametric equation of the line, so now we need to do the matrix multiplication. So from there, our x prime, y prime, z prime, to do the matrix multiplication, we need to take 1 times 2 plus lambda, negative 1 times negative 3 plus lambda, and 1 times negative 4 minus lambda. We get this. Okay, now for y prime, we need to take 3 times 2 plus lambda, we get 6 plus 3 lambda. 0 times negative 3 plus lambda is 0, and then negative 2 times negative 4 minus lambda is positive 8 plus 2 lambda. What about z prime? We need to take 0 times 2 plus lambda, which is 0, 1 times negative 3 plus lambda, it remains unchanged, and then 1 times negative 4 minus lambda, it remains unchanged. Now we need to simplify, and when we simplify, we are going to get x prime to be 1 minus lambda, y prime to be 14 plus 5 lambda, and z prime to be negative 7. So the parametric equation of the image of the line is given by this. Okay, now we could actually end here. Okay, since it was not specified for us to get, they just said find the image of the line, so we could allow the answer as in parametric form, or in Cartesian form, or in vector form. So I'm going to write all the forms. Now this is a parametric equation of the image. So how do I get a Cartesian equation of the image? I just introduced this 0 lambda here just to explain a certain concept. Okay, so to get a Cartesian equation, I need to find lambda in all the equations. That's the first reason why I needed to introduce a 0 lambda here, so that I'll be able to find lambda here. Okay, so I find lambda in the first equation, I find lambda in the second equation, and I find lambda in the third equation. Mathematically, this third line is incorrect. Okay, but because I want to explain something, I will need to do it, though it is mathematically inappropriate to divide by 0, but I'm just trying to explain something to you, how you can use the Cartesian equation to now get the parametric note, to now get a vector equation. So the vector equation, this is what I'm going to do. My arrow prime, because x prime, y prime, z prime will be equal to the coordinate you find here, 1, is the position vector, that's the x coordinate, the I component of the position vector. So 1i plus 14j minus 7k. Okay, so these negative signs, these original negative signs are supposed to be there. All right, so we now deduce the position vector to be I plus 14j minus 7k. Then now what about the direction vector? We are going to now have the denominators. That's why you see that I needed to have a denominator here. Okay, like I said, it is mathematically inappropriate to divide by 0, but just to explain this concept I had to do so. So we have negative I plus 5j plus 0k. So basically, not putting the 0k there means that there is no coefficient of k. There's no coefficient of k in the direction vector. So this gives us the image of the line. We have the parametric equation, we have the Cartesian equation, and we have the vector equation. So you can put it in any form you want to put it in, since it was not precise in the equation, the particular form to use. Okay, now this is one of the most interesting parts of the equation, the image of the plane. Very interesting. It goes deeper and deeper and deeper and tests your understanding of vectors. Anyways, how do I find the image of a plane? Same story. The image of the plane is the matrix of transformation times the general point on the plane. So to get a general point on the plane, I need to use the fact that this is the equation of the plane, so I can find x. Okay, you could either find x, y, or z, but I decided to find x. So x is going to give me, I will need to subtract y and add z, so that I get negative y plus z. Then we add it to the 3, that is x. So the general point on the line, on the plane, sorry, in the place of x, I replace x with what I have, so y and z remain unchanged. If I decided to find y, okay, I'm going to instead replace my x and z will remain unchanged, and then I'm going to replace y with what I have in terms of x and z. But since I found x, then my y and z will remain unchanged. So the image of the line, sorry, the image of the plane is equal to the matrix of transformation times the general point on the plane. This is a general point on the plane. This point will satisfy the equation of the plane, because for you to satisfy the equation of the plane, your x coordinate plus your y coordinate minus your z coordinate must give you 3. Okay, anyways, let's do the matrix multiplication. So we multiply again. We need to take 1 times negative y plus z plus 3, then negative 1 times y, then 1 times z. We get what we have here. Now next we need to take 3 times negative 3 plus z plus 3, then we take 0 times y, and then we take negative 2 times z. We get this. Finally we take 0 times negative y plus z plus 3, we get 0. 1 times y is y, and the 1 times z is z, so we get y plus z. From there we just need to bring like terms together and simplify. Doing that, negative y minus y is negative 2y, z plus z is 2z and plus 3, negative 3y, there is no other y, so we just allow it like that. 3z minus 2z is z plus 9, and we are left with y plus z. So x prime is in terms of y and z, y prime is in terms of y and z, and z prime is in terms of y and z. So when we arrive in this type of situation, all we need to do is we need to eliminate y and z, and we have an equation that is linking x prime, y prime, and z prime. So to do that, we could consider these 3 equations. We use 2 equations and look for y and z, and then we replace in the equation we never used. Okay, since we have 3 equations with 2 unknowns, it's very solvable. Okay, so we are going to eliminate y and z, and I think we are going to choose equation 1 and equation 2, and then we find y and z. So let's start by eliminating y. To eliminate y, we are going to multiply equation 1 by 3 and equation 2 by 2, then we subtract the 2 equations. So equation 3 times equation 1 minus 2 times equation 2, what are we going to have? Now let's begin with the left hand side. 3 times x prime minus 2 times y prime, we get this. Now 3 times negative 2y minus 2 times negative 3y is 0, because you are going to get negative 6y minus negative 6y. Now 3 times 2z minus 2 times 2z, that's 6z minus 2z is 4z, and then 3 times 3 is 9, 2 times 9 is 18. 9 minus 18 is negative 9. Since we need to get z, we start by getting 4z. So 4z will give us 3x prime minus 2y prime plus 9. To avoid inconveniences, I'm going to allow 4z like that. Okay, I'm not going to divide all through by 4, and I'll tell you why. Because see, I'm using the first and second equation to find x, to find y and z. Then I'm going to replace the y and z in the third equation. So in the third equation, you'll be very possible to multiply by 4, so that I just replace the 4z with what I have. Now we now need to find y, since we have gotten 4z, and you realize that if I multiply equation 1 by 2, I'm going to get a 4z. Okay, then I just replace my 4z directly into the equation 1. So if I fit in equation 1, remember that if I take equation 1 times 2, I will have 2 times x prime to be negative 2y times 2, 2 times 2z times 2, and 3 times 2. We get this equation. Now in a place of 4z, I replace it with what I have here. So doing that, I get 2x prime to be equal to negative 4y plus, now what is 4z? It is 3x prime minus 2y prime plus 9. Then now we also need to add 6. 9 plus 6 is 15. Okay, so previously we had 4z to be 3x prime minus 2y prime plus 9, and there we also have 4y. If you find 4y from the previous, you're going to have x prime minus 2y prime plus 15. Now if I multiply the last equation by 4, like what I was saying, you realize that I get 4z prime equals to 4y plus 4z. Okay, so to get 4z prime, I just need to add these two equations. Once I take 4y plus 4z, I get 4z prime. So if I fit 4y and 4z in equation 3, what am I going to get? I am going to get 4z prime to be equal to, in the place of 4y, I replace it with this. In the place of 4z, I replace it with this. Now let us add corresponding entries. 3x prime plus x prime is 4x prime. Negative 2y prime minus 2y prime is negative 4y prime. 9 plus 15 is 24. It therefore means that this is the image of the original plane. So the image of this plane is still a plane. So the image is negative 4x plus 4y plus 4z equal to 24. Okay, if you divide all through by 4, you are going to get another plane which is parallel to this plane. Okay, but I'm not dividing all through by 4 because I need the original image. I don't need a plane that is parallel to the image. I need the original image. So we have negative 4x plus 4y plus 4z equal to 24. So the image of this plane is this. That is why objective was to eliminate y and z and have a single equation that is relating the x, y, and z coordinates of the images of x, y, and z. I am going to use another alternative method, okay, to find the image. So alternatively, we could identify the above equation as, now I'm going to pair negative 2y, negative 3y, and y. I call it one vector. Then I pair all the z's together, 2z, z, and z, another vector. And then since actually it was y plus z, we can just add 0. We have not changed anything, so that we have a vector 3, 9, 0. We realize that if we do the vector addition, we are going to get back to the previous system of equation. Now from here, we can basically start by writing the points first. Okay, when we write the point from this vector here, we need to factorize what is common, which is y. Factorizing y, we get negative 2, negative 3, 1. Here we need to factorize z, and if you factorize z, we get 2, 1, 1. So clearly, if you look at this is the vector equation of the plane. Okay, this is the image, and this is actually the vector equation of the plane. In the previous slide, we actually found the Cartesian equation of the plane. So this answer here is a vector equation of the plane because y and z could be lambdas. Okay, all right, so this, like I said, is a vector equation of the plane, and we can write it as 3i plus 9j, then plus, in the place of y, just replace it with another parameter lambda, into negative 2i minus 3j plus k, plus in the place of z, I replace it with mu. Then I have 2i plus j plus k. Now let us see how we can find the Cartesian equation of the plane, because this is actually the vector equation of a plane. Okay, this is a vector equation of a plane. So this vector equation of a plane, these are the characteristics. We have a point that the plane passes through, and then we have two direction vectors. These two direction vectors are the direction vectors of some two lines that the plane contains. All right, so I need to get the Cartesian equation of the plane, and to get that I need the normal vector of the plane, and the normal vector of the plane is a cross product of the direction vectors of the lines that the plane contain. Okay, so the normal vector will be the cross product of this and this. So to do the cross product of this vector and this vector, we need to use a determinant method, where we replace all the i's, -2 and 2. Here is it, all the j's, -3 and 1, and all the k's, 1 and 1. Now if we do the metrics, like finding determinant, okay, that's we are going to, when we cover I, we are going to get -3 minus 1, which is -4. Now when we cover j, we are going to get -2 minus 2, which is -4. But since j carries a negative, it becomes +4. Now when we cover k, we have -2 minus -6, that is -2 plus 6, which is +4. So at the end of the day, doing it correctly, we get -4i plus 4j plus 4k. So this is a normal vector to the plane. Now the Cartesian equation of the plane is given by arrow dot n to be equal to a dot n, where this arrow here is actually xyz, all the points on the plane. This n here is a normal vector. This a is the point that the plane passes through. In this case, the plane passes through the point 390. Okay, that is, this is a position vector of the point that the plane passes through. So arrow is all points on the plane xyz. N is a normal vector, -444. N is also the normal vector. Then we have a. Remember, a dot n and n dot a are the same. So 390, right? Now let's multiply. We have, to do the dot product, I just need to multiply and then I add. So I have -4x plus 4y plus 4z. Now also here I have -12 plus 36 plus 0. The -12 plus 36 is equal to 24. So you see, using this other method, we still get the same Cartesian equation of the plane. So tell me in the comment section which method is better for you. Do you prefer the first method or you prefer the second method? Anyways, with that, we have concluded the first part of the equation on linear transformations. Now let us move on to the second part of the equation, which is the application of calculus. Okay, now a curve is given by parametric equations x and y with theta in a certain range. We need to show that the length of the curve is 4 minus 2 root 3 units. So the arc length is actually given by L equal to the integral from, since I have parametric equations, then I'm going to have the integral from 0 to pi ln 3 of the square root of the x by d theta all squared plus dy by d theta all squared, and I'm integrating with respect to theta. I'm doing this because I have parametric equations and the interval has been given in terms of the parameter. Okay, if the interval was given in terms of x, then we could also, but anyways, you can still change it there. If you want to get it in terms of x, you can replace when theta is 0, we find the value of x. When theta is pi ln 3, we find the value of x, and then now we integrate, not using parametric equations again, but using the dy by dx after you use the chain rule. But anyways, you check this formula, you see it in the formula booklet. Once you have parametric equations, you can just go ahead with it. So my x was given as theta minus sine theta, so I need to get the x by the theta by differentiate both sides with respect to theta. Differentiate 1, you get differentiate theta, you get 1. Differentiate sine theta, you get cos theta. Now let's square. Okay, when I square the x by the theta, I need to square 1 minus cos theta, and squaring 1 minus cos theta, expanding, you're going to get cos square theta minus 2 cos theta plus 1. Now y is cos theta, so differentiating gives us negative sine theta, but once we square, we get positive sine square theta. Now what becomes of what is inside the square root? What is inside the square root will just be cos square theta minus 2 cos theta plus 1, then plus sine square theta. Though I brought sine square theta in front because I know that cos square theta plus sine square theta is equal to 1. Now 1 plus 1 is equal to 2. Okay, now What is 2 minus 2 cos theta? You realize that if I introduce it into this square root, it will be very difficult for me to integrate. Okay, so you need to think about what will you do to have, because to integrate a square root of something, if that thing is something squared, the square root will just cancel, provided it's in a positive region. So if I am able to convert 2 minus 2 cos theta to something that is that I can easily find the square root, then it will be very easy to integrate. So we are going to use the knowledge of trigonometry. The identity cos 2 theta is 2 cos square theta minus 1. Okay, so if cos 2 theta is 2 cos square theta minus 1, it therefore means that cos theta, I need to divide the angle by 2. It will be 2 cos square theta on 2 minus 1. That is, I have halved the angle. Alright, so the 1 and the 2 are not affected, just the angle is affected. If I halve the angle here, I'm going to be left with theta, so I need to also halve the angle. Okay, so from there now, if I multiply both sides by 2, because I can find a 2 cos theta here. Once I multiply both sides by 2, here I'm going to get 4, and here I'm going to get negative 2. Now I'm going to take 2 minus 2 cos theta. So I'll take 2 minus this value is the same as taking 2 minus all of this. If I take 2 minus all of this, you realize that the 4 cos square theta will carry a negative sign, but this negative 2 here will carry a positive sign because you are subtracting negative 2. So when you're taking 2 minus negative 2, you get 4. So you have 4 minus 4 cos square theta on 2. Okay, now from there you realize that you can factorize 4, and you're going to get 4 into 1 minus cos square theta on 2. But 1 minus cos squared of an angle is sine squared of the angle. That is the first identity. So 1 minus cos squared theta on 2 should definitely give us sine squared theta on 2. So you realize that we have converted it to something that you can easily find the square root. Okay, so the square root of this becomes the square root of 4 sine squared theta on 2, because you have realized that the integral is 4 sine squared theta on 2. The square root of 4 is 2, and the square root of sine squared theta on 2 is the absolute value of sine theta on 2. But anyways, since theta is in the interval 0 to pi ln 3, it means that theta on 2 will be in the interval 0 to pi ln 6, because we need to have the angles. Okay, so, and in the interval 0 to pi ln 6, the sign is positive, therefore means that we can just ignore the absolute value. So it means that the arc length will be, now in the place of the square root of all of that, I need to replace it with 2 sine theta on 2, then I'll integrate with respect to theta. Now once I integrate, to integrate sine we get negative cos, but we need to take 1 divided by, we differentiate the angle. When I differentiate theta on 2, I get half, but it is 1 over half, which will give me 2. But when I integrate sine, I get negative cos. That's it. Now the limits are from 0 to pi ln 3. So from there we just have to replace pi ln 3. When we replace pi ln 3 here, remember 2 times negative 2 is negative 4. When I replace pi ln 3 here, I get pi ln 6, because it's pi on 3 then on 2, pi ln 6. When I replace 0, I'm going to get cos 0. Now pi ln 6 is 30 degrees, and cos 30 is root 3 on 2. If I multiply all through by negative 4, this is what I'm going to have. Negative 4 on 2 is negative 2 root 3. Negative 4 times negative 1 is positive 4. So if I reverse, that is, I write it in a normal way so that the proof comes out, I'm going to get that the length of the curve in the required region is 4 minus 2 root 3 units. So finally we have come to the end of the video. Thank you guys for watching. Make sure you like the video, share the video, comment, and also subscribe. See you guys in the next video.